As we start our last module, Module 6, we're going to be going into some rather challenging material, and I strongly, again, urge you to read your textbook, and I will have a link up here to the textbook pages that we can use. And keep in mind we have additional examples that I'll also put a link to. Alright, so we're going to deal with what is called composite functions, and then later inverse functions. So there'll be background you'll need to be familiar with, and there is some special symbols that we'll be using. So let's go on to an example. The symbolism they're going to use looks like this, where we have in parentheses F, and there's a little circle, and then let's say a G, and this is read F composed of G, and then they give you a value 1. Then later they're going to ask G composed of F, where they've just reversed these two functions, and it will be a 1. So we'll start easy, and again you'll be taking notes. So in this first example they're asking us to take G, which is this here, and put a 1 to replace the X. So let's do that. We're going to put a 1 right there. So 1 squared is 1. 1 minus 4 is a negative 3. So when we put a 1 and replace it in our G function, we end up with a negative 3. We're now going to take this negative 3 and put it in our F function to replace the X. So this gives us then 2 times 3 is going to be 6. So for example A, in which we do this composition, our answer is 6. So what they're asking us is to take this value 1, put it in your G function. When it comes out of the G function, you put it in your F function. F composed of G. Alright, let's do the next one, in which we're going to reverse the order. This one here, G of F. We're going to put the 1 in the F function first, then put it in the G. And we'll do it over here. So I'll do this G composed of X in blue. So we're going to take the 1 now and put it in the F function first. So 2 times 1 will be 2. Now that we have this, we're going to take that 2 and put it in the X of the other function. So we get 2 squared minus 4. This will be 4 minus 4 is 0. So when we take f first, using 1 in its function, so g composed of f first, then we put it into the g, we end up here with a 0. And that's how we get these first two values. Now, in just a few moments, we're going to, instead of using a 1, we're going to just use the x. So let's clear this and work on that. Now, the same principle is working, but instead of using a 1, we're going to use an x. This is sort of like the general way of solving this. So f composed of g, where we're going to substitute an x into the function. So g then, this is our x. We're going to take this and bring it where the x is here. So f composed of g, this is what our x is. We're going to bring it here. So we then get 2 times x squared minus 4, and we just distribute 2x squared minus 8. So when we use the generic x here for f composed of g, we take the g function, that's our x, put it in our f function, replacing the x, and we get this. So for this one, it's going to be 2x squared minus 8. And if you look down below, these are the answers. Now let's do this one. Now in this case, let's change colors too. Our f function is this, which is now going to be our x that we replace the x with here. So our x there is 2x that we're going to square minus 4. So squaring this is 4x squared minus 4. And that's what this is. 4x squared minus 4. So in review, this is, again, for most of you, something new, where we're saying f composed of g. You find what that g value is, then put it in the f. And then you find the f value first, put it in the g. And we have the work here illustrating it. All right, we're going to do part B now. So we're going to clear this, but we're using the same protocol here. Now in our first example, we see again f composed of g, where we're substituting a 1. So we go to our new g function over here, which is 2 times 1 minus 1. We're substituting the 1 for the x. So this gives us a 2. 2 minus 1 is 1. So we take this 1 now and go into our other function, the f function, and now that we've found out what this is, we substitute it there, and this becomes the square root of 1 plus 3, which is the square root of 4, which equals 2. So for in example B now, where we're taking f composed of g, this will be a 2. Now we're going to do the 1 here. Now in the second part, letter B, where we're going to substitute a 1, but now we're going to do G composed of F, where we're going to use a 1. So right here we do the F function first. This is the square root of 1 plus 3 will be the square root of 4, which is 2. We now take this 2 from our F function and put it in our G function. So this would be 2 times 2 minus 1. 4 minus 1 is 3. So for this second part, where we have G composed of F when it's 1, we end up with a 3. And then we'll erase this and put in our generic X. Now when we put our X in there, again it's F composed of G. Well, this is going to be our X value right there. So we go under our radical sign, and where X is, we put 2x minus 1 plus 3. And when we simplify this, we get the square root of 2x plus 2. So we'll put that right here. The square root of 2x plus 2. Alright, now again, having this set up saved me a lot of time, but I want to be sure you understand what's going on. So here we have G composed of F when we're going to substitute the X. So here, this is our F function. So in a sense, our new X is this. We're going to bring this over to the other function, G, and we're going to substitute 2 the square root of x plus 3 minus 1. And that's all that it is. 2 the square root of x plus 3 minus 1. And you have to be careful when you're writing the radical sign, you don't extend it over to the negative 1. Okay, now if I were a student and I wanted to be sure I knew this, I would go back to the beginning or write these out on a separate sheet of paper and try them to see if in fact you've mastered the concept of what's going on here, where we are looking at the compositions of F composed with G, and then later G composed with F. Now we'll go on to letter C. Now in some of our earlier lessons, we would have the answer like x equals 3 and x equals negative 2, and we had to find the original equation. This would be x minus 3, x plus 2, and then we would FOIL that and get our equation. These were the answers, and then we ended up with what our original equation was. Well, this is sort of like that in a way, because now we're saying this function h of x is actually a composition that was made up of this. That is F composed with G. So this is the answer now. What they're asking us to do here is to tease this apart, and what would it have been originally? Okay. So what we're looking for here, and it's F composed of G, so we're looking for an F function, and we're looking for a G function, that when F is composed of G, it becomes this. Now, here it takes a little bit of creative thought, and I do have other exercises where I go through a lot of these if you want more practice. Of course, you'll be doing some in Math Lab as well. But what could G have been initially here? What would F then have been initially if we have F composed of G? Well, if G was 3x minus 7, which is what is under the radical sign, and F was the fifth root of x, then this would be the composition of this, where we would take this and substitute it for the x here, and you get that. So again, it is challenging, and hopefully you're starting to see what's going on. And if you need more practice, there is. And again, there's always your textbook. Now, for number 2, I need to give you some background. And it's asking us to determine whether the function, now they are saying this is a function, has a one-to-one relation, and thus has an inverse that is a function. And for this, again, in your textbook, they give you lots of background. I will summarize it here for you. Well, if we were to graph this function on a graphing calculator, it looks like this. Starts at 0, and it goes like so. Now, let's prove that this is a function. Well, we said earlier that if we had a vertical line, which is this blue line right here, and let me draw this on each one of these. If we move this blue line over the face of the graph, it only intersects our function in one place at a time, which is this up here. So this is in fact a function. The vertical line test, it passes the vertical line test, so it is a function. And they're saying it's a function. But they're wondering, is it a one-to-one relation? Now, in order to prove something is a one-to-one, we use what is called the horizontal line test. Now we're going to take this horizontal line and move it over the face of this function, which is the square root of x, in a graph form. Well, as it comes down, and this actually goes up a little bit, and it does pass the horizontal line test. Passes the vertical line test, it's a function. It's saying that it is a function. But does it pass the vertical line test? I'm sorry, the horizontal line test. And it does. Therefore, this has a one-to-one relationship, this function, and it does have an inverse. And again, I'm just sketching these. So once again, it is a function, passes the vertical line test. It has a one-to-one because it passes the horizontal line test, therefore has an inverse. That's what they're asking here. So in the future, they will ask this type of question, and they will say, does this function, is it a one-to-one? Does it have an inverse? And this is the protocol we use to find it out. So you'll have to know a little bit about graphing, and you can always use your graphing calculator if you have one, or one that's online to do your graph if that's needed. Now, for example 3, they're asking us to determine whether each function, now they're saying these are functions, is a one-to-one. And if so, find its formula, which is the inverse of what is there. Again, I'll give you some background on this step by step of what they're asking and how to determine it. And again, lots more information in your textbook. Now, this is the graph of this function. Does it pass the vertical line test? Yes. Does this one pass the vertical line test? Yes. Does this one pass the vertical line test? Yes, they all pass the vertical line test. So they are functions. They're saying that they are functions. Now the question is, does it pass the horizontal line test? This one does. How about this one? Yes, that does. How about this one? This one doesn't, because as it comes down, intersects there and there. Okay, here it only intersects once as it comes down, the horizontal line test. So these two have an inverse, but this one doesn't. Why not? Because where it is a function, it doesn't pass the horizontal line test, and therefore is not one-to-one. Again, some basic definitions here. These are functions, but in order to have a one-to-one relation, it must pass the horizontal line test. These two do pass it. This does not. So therefore this one does not have a one-to-one. That's the background of this. Now let's go on to find the formulas for finding the inverse. Now this symbol is read F inverse of x. This is not a negative exponent. This is the function symbol for the inverse. This is read F inverse. Now, I'm going to go through for this one and take good notes, the recipe for finding the inverse of a function. Step 1 is to change our function symbol to a y. Second is to exchange the x and the y. So again, first step, substitute y for the function symbol. Now, reverse the x and y. Now, solve for y. We just transpose the 3, and we get x plus 3 equals y. Now, take the y and substitute the inverse symbol, and we can put it over here. So this is our new y. So, step 1, substitute a y for the function symbol. Switch the x and the y. Solve for y. Then substitute the inverse symbol for the y, and this is the answer to 3a. Now 3b, exactly the same way, and I'll change colors for emphasis. We're going to substitute the letter y for our function symbol. We're now going to exchange the x and y. We're now going to solve for y. So we transpose the 7 to this side and divide everything by 4. So I've transposed the positive 7. On this side became a negative 7. Then I divided both sides by 4. Now I'm going to change the y with the inverse symbol. F inverse equals x minus 7 over 4. Now, for some of you, and hopefully the helpful part of this is that you can go back and replay it and be sure you understand the process. Let's go on. Now, here we get a chance to use lots of our skills because they're asking us to first find the inverse of this and then graph both of these on the same set of axes. So, what would be the inverse of this? Well, let's find the inverse. So we're going to go y equals a negative 3x plus 6. So we're going to switch now the x and the y. Now we're going to solve for the y. So, to find the inverse of this, once again, we substitute a y for the function symbol. We then switch the x and the y. And then now I want to solve for a positive y. So I've taken this, transpose it to the other side. I've taken my x, transpose this to the other side, and now I've divided everything by 3, and I get this. So we have two graphs that we're going to plot on this line. One is y equals a negative 3x plus 6, and then its inverse. So let's do that. Now I'll do this in stages so you can see that when we plot this line, our y-intercept is 6, our slope is over 1 down 3, over 1 down 3, So this gives us this line. Oop. Now on the same graph, I'm going to plot this one, where our y-intercept is going to be 2, and I'll put that in blue. So there is my inverse, and notice they're intersecting right here, and we want to give you just one other line, and I want to put in what is called the axis of symmetry. Now, an interesting thing about a function and its inverse, if you were to fold this along the axis of symmetry, you could somehow fold this, you would see that these two lines are mirror images, that is, would go right on top of each other. In fact, I have a little video that I show that in some detail. But again, what we're showing here is this function, its inverse, and plotting them on the same axis. Okay, and we're building up to something, as you may or may not see as we move on. Okay, let's go on to our last example. And they're charging us with using composition to show that this and this is the function, this is the inverse. So let's go through the proof. So we're going to change this to y. Y equals the third root of x plus 3. So we're going to go through the procedure of finding the inverse. Now the rule is exchange the x and the y. So this now becomes a y here. And now we're asked to solve for y. Well, how do we get the y from under the radical? Well, you may recall we have to raise this to the index number power, and if we do it to that side, we must do it to this side. So we now have x to the third equals y plus 3. That is the radicand. Now when we solve for y, we get x to the third, transpose the positive 3, and now we write the y in the inverse symbol, and you see we have proven through composition that this is the inverse of that. And, you know, I always think the teacher makes it look easy. Well, remember, I've studied this also, and I've read the textbook, I've done the additional exercises, and I've worked to earn mastery of this. And my, in a sense, a gift to you is that I've recorded this so that you can see it again and again until you get mastery. And good luck.